Rocks are all around us, and every rock you see used to be different. Over time, rocks change. They break down, wear away, or even melt, but never disappear. How do rocks transform from this to this? Let's find out together in this episode all about the rock cycle. There are 3 types of rock found on Earth: metamorphic, sedimentary, and igneous rock. We can classify each type of rock by how it was formed. Sometimes rocks form quickly, like when an erupting volcano spews molten rock into the air. And sometimes they change slowly, like when a rock is heated and compressed below Earth's surface for thousands or even millions of years. When you're looking at a rock, you're looking at history. Rocks may all seem the same at first, but they're all different and complex. The rock cycle shows how each type is formed in a different way, or how Earth's materials, driven by energy flow, change over time through melting, crystallization, weathering, erosion, and deformation. Within the Earth's crust and beneath the surface is molten rock, or magma, that can cool and solidify and turn into igneous rock. Let's take a look at Earth's layers to help us understand how this is possible. The Earth is made up of several layers that go all the way down to its core. The top layer of the Earth is slowly moving and shifting and is called the lithosphere. This layer consists of the Earth's crust and part of the upper mantle and makes up the tectonic plates, sometimes called lithospheric plates. These tectonic plates are being pushed together, pulled apart, or sliding past each other along surface faults. These movements are what create mountain ranges, seafloor trenches, and volcanoes. On the west coast of the United States, 2 plates are converging. The Pacific plate is going underneath the North American plate and begins to melt as it moves farther and farther down, eventually forming Mount Rainier and Mount St. Helens, which are active volcanoes. Old oceanic crust is constantly being recycled in the subduction zones. This is where oceanic crust, being more dense, is subducted or sinks below the continental crust, where it melts and is recycled into the mantle. Volcanoes like this are a great place to find molten rock and igneous rock. You can see this action modeled here. At the bottom of this beaker, I have wax to represent magma under the crust. A layer of sand is resting on top to represent a thin layer of oceanic crust. As the magma rises, it cools and solidifies. When magma comes to the surface, it makes brand new rocks. Any new rock that has changed from molten to solid is an igneous rock. Igneous rocks make up about 90% of Earth's crust, though you may not notice because they are covered up by other rocks, soil, or ocean. One common kind of igneous rock is granite. Behind me is enchanted rock, a massive 425-foot high, 1.1 billion year old pink granite dome. Here is an exfoliated piece for us to get a closer look. Another type of igneous rock is this obsidian, which is smooth and glassy. Both of these rocks were made of molten rock, so why do they look so different? Depending on whether magma cools above or below Earth's surface will determine the type of igneous rock that is formed. When magma cools and solidifies beneath Earth's surface, it forms intrusive igneous rock. This granite is intrusive igneous rock. It has only been exposed by erosion or the removal of the surrounding rock. Intrusive rocks like this cool slowly, so they have more time for larger mineral crystals to form, which is why granite looks coarse-grained, and we can see the crystals even without a microscope. When magma erupts to the surface, we call it lava. After lava cools and solidifies, it becomes extrusive igneous rock. This obsidian is volcanic glass, formed when lava cools rapidly with minimal crystal growth. If you're still here, liking this video, let us know. And hit that subscribe button so you never miss an episode. Once an igneous rock like granite is created, its journey isn't over. The rock begins to change through a process called weathering. Weathering wears away at exposed surfaces over time. It's the breakdown of rocks and minerals into smaller pieces or sediments. Rushing water in rivers can wear down sharp edges on rocks over time. High temperatures cause rock to expand, and falling temperatures cause rock to contract. As this cycle happens over and over again, the structure of the rock weakens. Eventually, the outer layers flake off in thin sheets, a process called exfoliation. That's what is happening here. You can see the curved cracks in peeling sheets. Looks a bit like a giant rock onion. All this sediment can be moved around or eroded by wind and water. Eventually, it will be deposited somewhere, joining sediment from other rocks at the bottom of a riverbed, lake, or ocean. Under the right circumstances, sediments can form into sedimentary rock. All the material in this sandstone once belonged to other rocks. These sedimentary rocks behind me were formed over 250 million years through the deposition of sediments in ancient seas and rivers, creating layers of red shale, sandstone, and gypsum. Rocks like these are formed when sediments undergo lithification. Before lithification can occur, we need sediments. So I'm going to create some candy sediments. This is taking a long time, so let's speed it up. That's better. The first step to lithification is called deposition. This is when sediment is deposited in a new location and it spreads out to form a layer. As more and more layers are created, the layers underneath them become pressed together. This is called compaction. Minerals settle between the sediment particles, which makes everything stick together. This is called cementation, like cement. This is now our candy sedimentary rock. You can see the layers. We started with the white and ended with the green. With enough heat or pressure, a metamorphic rock can be formed from any other type of rock, igneous, sedimentary, or even other metamorphic rocks. All of the minerals in the original rock recrystallize without having to melt down back into molten rock. The new metamorphic rocks are typically harder, more compact, and more resistant to weathering. Metamorphic means it's changed. We can create metamorphic rock with our sedimentary candy rock by adding heat and pressure. First, I'm going to use an old hairdryer to heat things up. Now, squishing action. Pressure! Squish! Pressure! Our sedimentary rock is now a metamorphic rock. These pink rock islands jutting up through the limestone are metamorphic rocks, called Valley Spring Gneiss. Intense heat and pressure applied to the original rocks over millions of years formed gneiss. The original rocks were sedimentary and igneous, likely granite. Rocks really never go away. They're changed and reused over time. This metamorphic rock can be heated up until it becomes like liquid lava. Once it cools, it's now an igneous rock. Back to the beginning. There are many pathways through the rock cycle. Metamorphic rocks and sedimentary rocks can become igneous rocks when they're melted and then cooled. Igneous rocks and sedimentary rocks can become metamorphic rocks when they're exposed to high heat and pressure. Igneous and metamorphic rocks can become sedimentary rocks if they're broken apart into sediments and go through lithification. So the next time you spot an interesting rock, see if you can tell. Is it sedimentary, igneous, or metamorphic? And if you want to learn more science, you can check out this video next. Pressure!